All right, here's another circuit problem that we want to solve. And as usual, we're going to start just by making a chart. So in this case, we've got, again, always V, I, and R. We have three resistors in this, X, Y, Z. And as always, you want to have a total. And again, I'm just a little picky. I'm going to make my grid just to help me a little bit. All right, so there's my chart. Let's fill in what we know. So the total voltage is 20 volts. So under voltage and total, I'm going to write 20 volts as my total. The total current is 4.5 amps. And then it gives me some information that X has a resistance of 60 ohms and that Y has a resistance of 40 ohms. And my goal, how much current goes through resistor Z. So I'm looking for this, the current I through resistor Z. And I got to figure out how to approach this. So first off, what kind of circuit is this? So we look at our battery and say, are there multiple paths for the electricity to travel? And so there are. Go this way, go this way. There are three different paths for the electricity to travel around the circuit, which makes it, by definition, a parallel circuit. Remember, series only had one path. So a parallel circuit has a few rules. One is that the voltages are all the same, because every single bulb or resistor gets the full force of the battery pushing through it. You don't have to dilute it by going through multiple things. So the voltages are all the same, the currents are all going to add up, and the resistance is a little more complicated. We'll hold off on that for now. But for now, the key thing about parallel is once you know one voltage, you know them all. So if we know there's 20 volts, we know all of them are 20 volts. And that's going to be really big in helping us because now we have 2 out of 3. Once you have 2 out of 3 in any row, you can solve for the third because we know, which is true for this circuit as all circuits, that V equals I times R. So along for X, we can say 20 equals I times R, which is 60. So I can solve for that I by dividing by 60. So if I do that, I get 0.33, and I'm rounding slightly. If you want to confirm this, multiply I times R and make sure you get V. So 0.33 times 60 gives me about 20. That checks out. I'm going to do the same thing for Y. V, 20 equals I, unknown, times R, which is 40. I'll divide each side by 40, and I'll get I equals 0.5. Again, I can confirm that. 40 times 0.5 is 20. It checks out. So now what? Well, I have current. I know my total current is 4.5, and I know that two of my things, I get 0.33 amps through X, and I've got 0.5 amps through Y. So how much is traveling through Z? It's the difference. I have to subtract from the 4.5 to figure out the total amount of current traveling through here. And so if I do that, I get 3.67 amps, which I could stop here because this is technically what I was looking for. This is what I could submit. But if I want to just confirm, or I guess it won't be as helpful to confirm this one, but I can go and finish this, find the resistor for Z. So 20 equals 3.67 times R. So I would do 20 divided by 3.67, and I would get the R is 5.45 for resistor Z. And then if I wanted to find the total resistance, I would do 20 divided by 4.5 and get 4.44. And I guess this is not as helpful to confirm your answer, but remember in parallel, your total resistance, this number has to be lower than all of these other numbers. And so 4.44 is in fact lower than all these. That is a small confirmation. I guess we did it right. But anyway, this is our final answer, that the current passing through Z is 3.67 amps. So anyway, these problems certainly take a lot of practice. You definitely want to try them out, check your work, right? I times R equals V for every single one. You always double check that. Make sure that the voltages are all the same if it's parallel. The currents add up if it's parallel. But that's about it. So try these out, practice them. If you make a mistake, look at the answer, try to fix it and see that it matches up. But that's it. So until next time, I am Derek Genova. Have a delightful day.